first, okay, about that passcode. Okay, how come we have so many passcodes? Okay, it's because I actually asked the department to assign one additional classroom to this class. Okay, so so next time, if you come to this class and you cannot find a seat, okay, you can go to the A203, okay, A203, okay. But you have to bring your computer with you because we are going to make this class like kind of like streaming, okay, like maybe YouTube streaming， 变那个 YouTube 直播之类的 ，OK， 所以 so I will become like a 网红 something like that, OK, yeah, so， 诶，那个遥控器在哪边？这个，well, it doesn't work. Okay, so but consider like I don't take attendance. So the good news is that like after the first class, I think like a lot of students will not come. So we should be able to go with this classroom. Okay, I mean after I still prefer like you guys like to have like a face-to-face lecture. Okay, so let's get started. Okay, so this is the first handout. I think I have the student to print my TA to print like enough content for you guys like for at least for today's class. Okay, and as I said when I went through the syllabus, after this class, okay, if you need additional handout, I will make sure all the handout, all necessary handout be available on eClass to download at least a week prior to my class. Okay, so but you need to do it yourself. Okay, we are not going to print additional handout for you because, well, it's not like everybody needs like a printout handout anyway, right? A lot of students just use like a PDF file to read it like on the computer directly anyway. Okay, so anyway, just want you guys to be aware. Okay, so to download the handout yourself. Okay, next time. So this class, okay, we are trying to use the data to solve the problem. Okay, so in computer science, okay, the traditional approach for problem solving, okay, is that, okay, you have a problem, okay, so you have a good look at the problem and you study on that problem, and then, okay, based on your understanding with the problem, you write rules, okay, and use those rules to solve the problem. Okay, so obviously the rules you used, okay, I mean once you make it a program, okay, you are able to evaluate, okay, I mean your program, if it runs well, okay, if it solves your problem, I mean everything's great, okay, you just launch it, okay, without any problem. But if there's any issue, okay, with the solution, okay, it means something's wrong with your rules, which obviously should go back to your problem understanding. So you have to analyze the error and then find most of the time, I mean, it should give you better understanding of the problem. So you probably will have to write, to revise your rules, okay, revise your rules, and eventually, okay, write a second version, okay, and then you evaluate that, okay. Basically, this is a loop, okay. You keep doing that until your problem gets resolved, okay. So obviously, okay, in this process, okay, this traditional approach require a lot of manual work, okay. I mean, we humans have to involve in a lot of, I mean, a lot of places in this process. For example, study a problem, obviously, is done by the human, okay? And the evaluation, once you have some error, okay, the analyze the error part, obviously, is done by human too, okay? And, from the problem study to coming up the rules, normally, this is also done by the human. So this process, like, it's, even though it's a traditional approach, it is not ideal. It's not ideal. Okay. So when machine learning come into play, okay, you still study the problem, okay, and then based on your idea, okay, you are going to train a machine learning algorithm, okay, and so you can see that the whole process, okay, is kind of similar to the previous one, right? It is because, okay, in machine learning area, okay, here, okay, I'm not talking about deep learning, okay. So you may ask, what is the difference between machine learning and deep learning? Okay, to be honest with you, okay, a lot of places they consider deep learning as a part of machine learning, okay. But now I'm trying to, when I refer to machine learning here, I'm trying not to refer to deep learning, okay, because the traditional machine learning does not require so much data, okay. I mean, you can. For example, like in traditional machine learning, okay, a lot of algorithms perhaps require only like, hundreds of entries of data, or at most thousands of data, and you are able to have a pretty satisfactory result, okay. But obviously, in deep learning, you require much more than that, okay. So in the machine learning, as I said, okay, you don't have that much data, okay, so you still study the problem. Because the data, as I said, I mean, it's not a lot, so you normally cannot, cannot study just the data. You have to study the problem itself, okay, and then based on the property of the problem, as well as maybe the small amount of data that you have at hand, you decide like which algorithm to use, okay, which machine learning algorithm to use. But you can see that, okay, this process, okay, still like there's a lot of manual work, okay, and it's difficult to automate, okay, it's difficult to make the whole process like as less human involvement as much. Okay, so now, okay, one way to do it is that, okay, here, okay, the machine learning that automatically adapts to change is like, now we have a lot of data. Okay, this is more like deep learning stuff, okay? So from the data, the problem is actually defined by the data directly, okay? And then you basically like, you can use the data to train your algorithm, okay? So in this scenario, pretty much you have a lot of data. So a lot of time, the machine learning algorithm that you use, okay, can be like a deep learning, okay? and then you evaluate the solution. Okay, if it's good, you launch it. Okay, and because the algorithm, the solution is normally comes directly from the data. Okay, normally it's not going to be an issue for the current data because data itself is the problem, right? But obviously, data could change, right? You may collect more data, or the data may be obsolete, okay, in the future, okay. So, I mean, so if the data gets updated, I mean, you may need to go through the whole process again. But this whole process does not require a human to analyze the problem anymore, okay? So this whole process can be automated much better than the traditional or like the previous schema, okay? So this is something we would like to achieve. Actually, okay, not only that, okay, with lots of data, okay, we even expect the machine learning or deep learning algorithm to teach us the property of some problems, okay? So because I mean you have lots of data, so you are able to have train the algorithm to solve this problem, and from this solution, okay, we human can inspect the solution and get a better understanding of the problem, okay, and then so this is like the machine learning actually is used to help us human to understand the problem because as I say, like the problem actually, I mean, is now defined by a lot of data, but it's not well defined. Okay, a lot of time, I mean, this type of problem is not well defined, so it's very difficult to study a problem directly. Okay, instead you use this data to derive algorithm, and then use the solution to help you to understand the original problem. Okay, let me use one example. Okay, you guys know AlphaGo, right? AlphaGo is one of the well-known example about deep learning, right? I mean, it has been used to beat the professional like Go players, okay? And we know like how difficult the Go game is, right? So, I mean, now like in Japan, like every time they play like professional Go games, okay, like Minren or like Qisheng, okay. I mean, every title game, basically there's like how should I say, like kind of like the AI score behind like the player. So every time a player plays one move, okay, the score actually gets changed. So basically you can sort of consider like that's like one way to evaluate how good that player's move is. Okay, I mean, in the traditional Go area, normally, I mean, we cannot like judge a move so easily. Okay, we need to start. I mean, a lot of professional Go players need to study the move, like spend so much time to understand the move. But now, okay, with that simple score, we can sort of very easily to understand, like, oh, this move is extremely bad, or this move is like well, it's relatively okay, something like that. So that actually that machine learning or like deep learning model, okay, behind the game actually is used to help us human to understand the Go game much better. Okay, because I play Go games, okay, myself. I'm an amateur 1D, okay, amateur 1D. If any of you like to play Go games, okay, let me know, okay. Maybe if you beat me, okay, you get some points, okay. Yeah, just kidding, yeah. Okay, so that's even though the machine learning or like deep learning, I mean, in this class, okay, that we are talking about, okay, I mean, it's good, okay, as I already mentioned, it's a benefit to us, but machine learning or deep learning is hard, okay, why? Okay, here I list a number of issues, okay, for the machine learning. The first part, okay, is about data, okay. Is your data, okay, are your data representative to this problem that you are studying, okay? So representativeness of your data is important, okay? For example, okay, sometimes when you collect the data, okay, you may correct like wrong samples. So for example, okay, let me, because recently like I think like at the end of this before the end of this this year or early next year, we will have an election, right, in Taiwan. Okay, so if you go, I mean, if you you know turn on the like a TV, like there's a lot of like a program like debating like okay, which candidate is good, which candidate is bad, something like that, right? Okay, so you know like a certain channel is maybe pro certain like a party, right? Okay, so I mean the you know the study, okay, that is done by certain channel, okay, may have bias. We know that, right? So maybe they will ask like, okay, if the channel will ask, if you support particular candidate, please call in. If you support the other candidate, please call in. And different channel will get totally different results, right? Okay, so maybe like this channel is good, is favor, it's more like a DPP, like a preference or preferred. So it will get like a, you know, the DPP supporters will tend to call into that channel, will tend to watch that channel. The other channel maybe like it's it favor KMT candidates, so it will get more calling from the KMT supporters, right? So you can see that, okay, different channels will have very different results, okay? I mean, they both collect data, right? They both collect data, but their data may not be representative for the current situation, okay? So that's the issue, okay? And another problem is the data balance, okay? This is especially a problem in the classification, okay? For example, if you want to design have a model that do like classifications, okay? Say we want to have a model that determine if a vehicle is going to, you know, trespass like a red light, okay, 闯红灯啊, okay, it's going to like go just drive through the red light, okay. You want to classify that this type of vehicle, I mean, to be like okay, this vehicle is not going to, it's going to stop for this red light, or this vehicle is going to you know, it's not going to stop for this red light, okay. When you collect the data for analysis, obviously you are going to collect, well, I'm assuming like Taiwan citizens are, most of them are abiding the law, right? Abide by the law, okay? So most of the drivers will stop for the red light, right? So you are going to collect very few sample, very, very tiny sample that will not stop for the red light, right? So maybe the ratio is like 100, in 100 drivers, only one of them is not going to stop for the red light, Okay, so 99% of the drivers will stop for red light. Okay, so if you use that data to train the model is going to tell you, okay, oh, no matter which driver drives the vehicle, okay, the model is going to tell you, okay, he's going to stop for red light. Why? Because if the model predict like that, it has 99% of accuracy, right? The model is smart, okay? The model is smart because it, from the data you feed to it, it derives that, okay, just directly predicting the vehicle will stop for red light gets the highest accuracy anyway, right? So it's not going to learn any particular feature whether this car is not going to stop for red light. Well, it's not, it doesn't matter. He just predict this car is going to stop. Okay, so the reason for this, okay, is because your data that you collected is very unbalanced. Maybe like a 99 versus 1. Okay, so that's the problem. Okay, so of course for each of these problems we have a way to deal with that. Okay, and also we have so many different machine learning algorithms out there. Okay, here, okay, if you are talking about machine learning algorithm, there are so many out there. Okay, but even for deep learning, we have many different approaches. Okay, as we will discuss in the future. Okay, so which algorithm do we use? Okay, and there are some algorithms that tend to have higher accuracy, but there are some algorithms that can give you better interpretability. Okay, you can explain why this model make this decision much better in certain model. Okay, so which consideration do you have? Okay, when you know it matters when you select like the machine learning algorithm. Okay, and also like which feature should you use, okay, to train the model. Okay, for one problem you may collect so many features. Okay, but you may not use all the features. Sometimes you will find that using only part of the features is actually better than using all the features. This is true. I mean, a lot of time. Okay, so which features to select? Okay, is an important issue, feature selection, and we also have like a consideration for example, such as optimizers. Okay, what optimizers to use? Okay, I mean, I will explain optimizer. I mean, later. Okay, in this class. Okay, we have so many different optimizers. Okay, sorry. Here, I mean, I'm talking about the cost function. Okay, cost function. It could be MSE. It could be entry, the binary cross entropy. Okay, something like that. Okay, depending on your problem, nature of the problem. Okay, and do you want your solution online solution or offline solution? That's also, I mean, the consideration that you may have, I mean, in machine learning algorithm determinations. Okay, and in terms of model performance, okay, you also need to consider, for example, okay, when you tune the model for better performance, okay, is your model underfitting or overfitting? Okay, if you don't know the term underfitting, overfitting, I will explain quickly. Okay, but of course, like if you in the machine learning class, I mean, they will probably spend more time, okay, to explain that. Okay, we are only going to spend, I mean, very short period of time to do that. Okay, and there's a trade-off between false positive and false negative. Okay, so what I mean, if you want to optimize false positive, I mean, you want to reduce false positive. Normally, the false negative will increase. If you want to reduce false negative, false positive normally will increase. Okay, but in some applications, false positive is important. Okay, you don't want false positive. In some application, you don't want the false negative. Depending on your application, you may want to get rid of one of them. Okay, but if these two are both bad, then you need to find a balance. Okay, a perfect balance to reduce both terms. Okay, so these considerations, okay, make the machine learning difficult. Okay. So in this class, our focus, okay, as I said, there are so many different machine learning algorithms, but we are only going to focus on the deep learning area, okay, which is like a much more popular branch in machine learning in recent history, okay, and we want to emphasize on the hand-on experience, in the sense that I want you guys to to not to focus that much on just the concept, but also focus on the writing codes. Okay, play with the algorithms. Okay, that is the reason you can see that this class, the only written part requirement is the final exam. We don't have any homework. Okay, everything else will be project based. Okay, I want you guys to work on the coding. Okay, so this is the hands-on experience is what I emphasize in this class. So, well, let's take 10 minutes break. When we come back, we will continue, okay? Yeah.